Hello and welcome to the fourth question of Applications to Trigonometry project. This question states, while hiking, Chris and Erica come to a point where two paths lead in different directions. Chris takes one path and Erica takes the other. The paths form a 70-degree angle at their intersection point. Chris walks along his path for 52 meters and then stops. Erica walks around her path for 64 meters and then stops. How far to the nearest meter is Chris from Erica when they stop? Okay, so here we have our actual question. How far to the nearest meter? So this is indicating that we are finding a side length in this question, and they give us uh, 1 degree. They give us a side length measure, and they give us a side length measure. Okay, so we're gonna begin. That's a little too big. All right, we're going to begin by drawing our triangle. Okay, we're going to label it A, B, and C. Okay, so Chris and Erica come to a point where two paths leads in two different directions, right? This point A can be their starting point, and one path leads here, another path leads here, two different directions. And the paths form a 70-degree angle at their intersection. They intersect here. So this is going to be 70 degrees. All right. Chris walks along his path for 52 meters. You can either put that 52 here or the 52 here. But we're just going to do it here. It doesn't really matter what you do, but we're going to do it right here. Chris walks along his path for 52 meters and then stops. So he walks and he stops. So at the moment, Chris is on points B. All right. Erica walks around her path for 64 meters and then stops. So she walked 64 meters to point C and she is right here. How far to the nearest meter is Chris and Erica? Is Chris from Erica when they stop? So we have to find the distance between them, which is the distance from B to C, right? This distance right here, this is our x component for our side length. We don't know this. Okay, so given side, angle, side, we can use the law of cosines in order to solve this problem. Okay, so we are going to have x squared. Let me make that a little bit better. X squared is equal to 52, no, 52 squared plus 64 squared minus 2 times 52 times 64 times the cosine of 70. Okay, so now this right side of the equation, the right hand side, we can plug in a calculator and we're going to be left with x squared is roughly equal to, then let's plug it in, plus 64 squared minus 2 times 52 times 64 times the cosine of 70. We have x squared is roughly equal to 5,661.756, actually 757. And in order to leave the x by itself like this, because this is our main goal right here, finding the x length, or, you know, instead of putting x, because we know that x just represents side length BC. So x and side length BC are interchangeable. So when we have our last step in order to find our unknown, we can just swap out x for side length of BC. We know that that is roughly equal to, uh, let's see, the square roots of, oh, I'm sorry, I didn't even put that here. So we can get like x from doing the square root on each side. And we can get that side length BC is roughly equal to 75 meters. Because remember, I asked for the how far to the nearest meter. The perfect answer would be around 75.2, something like that, but that rounds down to 75 meters. So that is our answer. Uh, I hope you guys know. And yeah.